Why are we so sure that there are black holes at the center of ours and perhaps every galaxy?
We see all this activity in the center of the galaxy, stars orbiting a big dark area.
Right.
How do we know it's not just like the center of a hurricane? The reason why we know that is because what we learned from Kepler and later Newton, the speed of your orbit is completely determined by the mass that's sitting inside your orbit. The mass around which you revolve.
Right.
So what you say is, here are these things, I can see how fast they're moving. Run back to Kepler's equation and say there must be a mass, a huge mass, bigger than the size of the orbit.
Wow.
Wait, and then you say, but wait a minute, we don't know anything that's that massive, that's smaller than the orbit, except for a black hole. So in other words, if it was a star with that much mass, it would be huge or
right.
some other thing, and you'd see it.
You'd see it, right.
You'd see a glowing thing.
Gotcha.
This is dark, and it has huge mass, and it's small. That's 3 smoking guns right there.
Right.
Implicating a supermassive black hole.
Supermassive black hole.
Yes. We're talking about hundreds of millions of times the mass of the sun, but it's a black hole, so it's small for that much mass.
Wow.
We hypothesize that maybe all galaxies have black holes. So you invoke Hubble, who can see farther away galaxies, and measure the movement of stars down deep in the middle, and they were moving fast too.
How big of an impact does dark energy have on my everyday life?
None. Okay, next question.
It's not always about you.
Okay, so the thing is, dark energy is this still mysterious pressure in the vacuum of space that's forcing the universe to accelerate in its expansion against the wishes of all the galaxies and their gravity trying to slow the thing down.
Right.
Some people thought of it as an anti-gravity force. Could we one day harness it and make spaceships out of it?
Right.
So there's an interesting sci-fi frontier there. But what I can tell you is, because it's manifesting in the vacuum relative to where there isn't a vacuum, there's not much vacuum here.
No.
Right? So gravity and electromagnetism and all these other things are really dominating where you happen to be. So, no.
Can a small black hole orbit a bigger black hole? And if so, can it be a stable orbit where it would never fall into or merge with the larger black hole?
Yes.
Boom.
Okay, next question.
Let's move on.
No. So, I don't think a black hole knows it's a black hole.
Really?
It's just a lump of mass out there looking for love, okay?
That's why it's a black hole.
In all the wrong places.
Now I get the black part.
No. So a way to answer that is, if Earth today turned into a black hole,
Right.
it'd be a mini black hole like the size of, I calculated once, about a plum.
Oh, really?
Yeah.
So you mean all of this Earth got down into the size
our
of a
event
plum.
horizon, it would be deep within the plum.
Right.
But the plum is the size of our event horizon. Okay?
With the mass of the Earth.
Yes! Black holes don't play, dude!
Ask Neil if a black hole can reignite into a star once it has lost enough mass through Hawking radiation.
Oh,
what
really?
a great
Good
question. Interesting.
Ooh. No. Okay.
There you go,
No,
Kent.
because if somehow the black hole could stay the same size and you pulled mass out,
Right.
then I don't know. I have to think that through. But what happens is, as you pull mass out, the black hole gets smaller and smaller and smaller to be the appropriate size black hole for the mass that's left over.
Okay.
Okay. So that's what's happening.
Does a black hole still produce light or other radiation that just can't escape the black hole's gravity?
Yeah, there's a lot of energy and matter inside of a black hole.
Right.
So if you're in the black hole, yeah,
It's probably bright as I don't know what.
Right, exactly.
'Cause the light got no place to go.
Right, it's got no place to go.
Yeah.
And so it's all in there. So now we don't have direct evidence of this. Chuck, you want to be Chuck, yo, call me and
I'll
when
go
you get
find
back.
this out. Let me go get on this.
You report back to me. I'm on a full report on my desk in the
I'll
morning.
be like Matthew McConaughey in that string theory movie.
Interstellar.
Interstellar, yes.
There's no reason why you wouldn't still see light and other things inside the black hole. If you tried to look outside the black hole, you'd see all the stuff coming in.
Oh, really?
Yeah. Oh, that'd be really bright.
That's kind of cool, actually.
Yeah.
Not a bad, yeah. The only problem is you just be like, don't come in here. Dark matter or dark energy. Is it possible to manipulate it, to use it as a fuel of some sort?
Here's the problem. Dark energy, we don't know how to interact with it. We just measure its effects on the universe. Dark matter reveals itself to us through its gravity, but it doesn't reveal itself to us in any other way that we normally interact.
So we can see its effects, but not what it is itself.
Not materially.
Not materially.
That's correct. Because
Wow.
materially, in order to have something, you are this person called Chuck.
Right.
Because all your atoms are all attached to each other.
Thank God.
Okay?
Yes.
They're all there.
Right.
Dark matter not only doesn't attach to your atoms,
Right.
it doesn't attach to itself. So, as far as we know, there are no lumps of dark matter out there.
Right.
There are no dark matter planets.
Right. You can see its effects, but you can't see it, and you
It is-
can't interact with
It
it.
is literally invisible.
How do you figure out what something is if you can't interact with it?
I know. Thank you.
He's like, welcome to my world.
I know. Thank you. This is the longest unsolved problem in astrophysics. It's been with us since 1936.
Wow.
Yeah.
What would happen to the Earth if it came close or directly in contact with a black hole?
I think about this all the time.
Oh, really?
Yeah. If Earth happened upon a black hole that was traveling through space, an encounter between Earth and a black hole, Earth loses.
Gotcha.
Okay?
Right.
Now, because we know about this tidal force that will stretch things, where the side of the Earth nearest the black hole will experience a much higher force of gravity than the side that's farthest, that means the side closest to the black hole will pull towards it faster than the side of the Earth. And so you'll end up stretching Earth. Earth is not made of rubber. Earth is made of sort of solid substance. Right. So if you're going to stretch, put under stress the solid sphere that is Earth, Earth will basically begin to crumble into smaller and smaller bits of rock.
So you're looking at massive earthquakes.
Oh, yeah. But it would happen pretty
and
quickly.
tidal waves. Oh, it would happen
Oh,
very
yeah,
quickly.
yeah. Oh, yeah. I mean, if you're falling straight in.
Right.
Oh. So, yeah. So Earth will distort, become more and more oblong until the strength of the materials can't hold that shape anymore.
Right.
And then it'll start sort of crumbling apart. We call that spaghettification, is when you start becoming this long strand. But again, spaghetti is one continuous string.
Right.
Whereas this will be a stream of particles.
That's right.
A parade of particles as they...
So is this Netflixication?
How do you get Netflix in there?
Streaming. How does a black hole not consume space-time itself?
Black holes are not any more voracious as black holes than they were as stars before they became black holes.
So it's really about mass.
It's just the mass.
It's just mass.
That's all. Think of the sun. How close can you get to the sun? You get near the surface and you just vaporize, okay? The sun's surface, its atmospheric surface, has a certain strength of gravity there.
Okay.
Right?
Okay.
Now let's cram the sun into a smaller volume. Same amount of mass, it's just denser. You can now get closer to the sun's center of mass. So its surface gravity is now higher. Cram it smaller. The surface gravity is even higher. Black holes are fun to think about and talk about because you can get close to them. If you get closer to Earth's center of mass, you're leaving half of Earth behind you, and it's not interesting.
Are other animals thinking about this kind of stuff that we're talking about right now? Are there dolphins just like, yeah, I'm telling you right now, man, there's something more than this ocean?
There's a comic, Gary Larson, you remember the illustrator? Yeah. There was a chicken, a horse, a cow, and some other farm animal in the barn.
Right.
They're having a conversation.
Yeah.
Okay? The chicken says, but if you divide by the square root of the mass, you get the same result. And then, like, the cow said, wait, but you're missing the basic premise of my theory. Well, and one of them looks out the window, farmer! Okay, the farmer's coming towards the and the farmer comes in, cluck, cluck, cluck.
Right, yeah, that's cool.
So you don't know if they're not talking that way when you're not looking?
No, I'm pretty sure they're not.
It's like the refrigerator light. How do you know?
Right.
You don't know if it's on or off
really
with the door closed. You don't know.